So today, first thing we do before we talk about limits is we're gonna not introduce, because you probably saw it last year, but it's called an asymptote. An asymptote. So an asymptote is a spot on the graph. So I think if let me see my last notes. I think we had an asymptote on our notes, or the notes before that, I should say. So, like if I take a look at this graph here, 5 has a vertical asymptote. I don't know why it's small like that, but 5 has a vertical asymptote. Okay? That's what it looks like visually. Why is it small? There you go. Okay? That's what it looks like. There's nothing there except a vertical asymptote. It's kind of like, so the graph can't go through it. It just hugs it. So you see, as I'm getting closer and closer to where 5 is, it hugs it, it gets closer, it just goes in one direction. It could either go, it has to go up or it has to go down. It can't go both ways, or it can't go multiple ways. Same thing over here, okay? So we're gonna look at situations like that. What happens when I get to that sort of thing? If I was like, where's the limit as x approaches 5? Okay, I think we had that, but we said does not exist because even though it's approaching the same number, infinity is not a number, right? We talked about that last time. Let's see, why does it keep getting small like that? I don't know why. Okay, so okay, so how do you find where an asymptote is? How do you know something has an asymptote, or how do you know that where the asymptote is, if you know it does? Well, the definition, this is the definition, it actually uses a limit, okay? But the easier way to do it is if this occurs whenever there is a value of x that gives you a 0 in the denominator, okay? So if wherever you can make 0 in the denominator, if the value of x gives you a 0 in both the numerator and denominator, that means a whole. So if I plug in a number and it gives me 0 on top and 0 on bottom, that's a whole. But if it gives you the denominator equaling 0, then so denominator, that's a vertical asymptote. VA for vertical asymptote. Okay? So the first thing we're going to do is find the vertical asymptote. If it has, will there always be a vertical asymptote? No. No. But first thing, it has to have a denominator, right? So if we look at 1a, we're going to focus only on the denominator. So that guy there, that's all we're focused on. Okay? We want to figure out where that's going to be 0. Well, set it equal to 0. Just set up an equation, 2x minus 4 equals 0. Okay? And solve it like you've done many, many, many times before. So we're going to add 4 to both sides, divide by 2, and it'll give you a value, right? 2x equals 4, divide by 2, and we figure out that x equals 2. So that means when x equals 2, so anytime I'm plugging in 2 to f of x, I'm going to get 0 on the bottom. So what does that tell me? That tells me I have a vertical asymptote at x equals 2. At x equals 2. Okay? Vertical asymptotes are always vertical, and they always start x equals. X equals. So if equations start x equals, that means it's going to be like that. Y equals, it's going to be the other way. Okay? Y equals the other way, x equals the other way. So it's only got one. It's only got one. Okay? How do I know it's not a whole at 2? How do I know it's not a whole instead of a vertical asymptote at 2? Plug it into the top. Do you get 0 on top as well? No, right? We get 3, right? So that means it's a vertical asymptote, okay? Not a whole. All right, so let's go to 1b. Okay. So again, vertical asymptotes, your whole, anytime you're looking for vertical asymptotes, all your focus goes to the top. Where is that going to be equal to 0? So x squared minus 4x plus 3 equals 0. Okay, it's a quadratic. How do I know that? Because x squared is the highest power, right? If squared is the highest power, it's a quadratic. So if it's a quadratic, how many answers am I going to get? 2. So let's find those 2 answers. Let's find those 2 answers. Okay, so let's see. A is 1, B is -4, C is 3. So we multiply A times C. B is -4, so we think, what are the 2 numbers that multiply to be 3 and add to be -4? -1, -3. A is 1, so we don't need to divide by anything, so we just say x minus 1 and x minus 3. You can divide by A, but A is just 1, so it's going to stay the same. Okay, last step. So remember, this equals 0, right? Because that's where we started, equals 0. How do we get our 2 answers? Because that's the factored version, but those aren't solutions. Solve for x, right? So we set them both equal to 0, and we get our 2 answers. Add 1 to both sides, add 3 to both sides. Looks like we have 2 answers. We got +1 and +3. So before we say they're both vertical asymptotes, we got to check it out. Maybe one's a hole. So when I plug in 1, you don't have to plug in 1 to the bottom because we already know that equals 0, right? We're good there. But when I plug it into the top, is it also going to give me 0? Yeah, right? So 1 is in a vertical asymptote. 1 is actually a hole on a graph. Okay. 3, when we plug it into the top, we get -2. So 3 is a vertical asymptote. So if they're just asking for vertical asymptotes, we just want 3. We don't want the 1, because that's a hole. Hole is those open dots that you saw the other day. Last week when we had notes, those open dots, those are holes. Vertical asymptotes are the guys that the straight dashed lines. All right. Sometimes you can do it in your head. Like look at C. Without doing any math, what number would I plug in to the bottom to make 0? -1, right? Yeah, if you can do it in your head, that's fine. Let's say you didn't see that. Well, you would just set the bottom equal to 0, right? And we do the same thing. Why do I keep doing that? So if I want to solve this equation, what's the first thing I got to do? Square root, right? To get rid of the squared is the opposite. Square root is the opposite, I should say. So we have x plus 1 equals, so anytime we take a square root and we're solving, right, we have a plus and a minus. We always have 2 answers, right? Unless it's 0. Because the square root, there's no such thing as a +0 and a -0. So it's just 0. But let's say that number was like a 9. Then it would be positive and -3, right? Because +3 times +3 makes 9. -3 times -3 also makes 9. So just remember that, if that ever comes up. And then subtract 1 from both sides, and we get the answer that some of you already had in your head, right? So is that a vertical asymptote, or is that a hole? Oops. It's going to be a vertical asymptote, because I don't have anywhere to plug it in on top. Don't got anywhere to plug it in on top. It's already 1. So it can't be 0 on top. Okay. All right. What does that all have to do with limits? Because we didn't do any limits, right? Well, now we're going to mix in the limits. So what do you notice about the limiting? What do you notice? Look at the limiting value. The limit value. What do you notice about it? It's only coming from the left, right? It's a one-sided limit. Good. Okay. Go back a few days. What's the thing we should remember about one-sided limits? There's always going to be a solution. Yeah, there's always going to be. We can't get D and E for one-sided limits. Okay, so one-sided limits will never be D and E. So if you have a one-sided limit, sometimes your instincts will be like, oh, it does not exist. Well, not if it's a one-sided. If it's a two-sided limit, yeah, you could get D and E, right? But not if it's a one-sided limit. Okay, so let's go back to our last set of notes. What's the first thing we always try? What's the first thing we always do if we get a limit? We're doing a limit problem like this. Plug it in. So let's plug it in. You just plug in 2. Don't worry about the negative or the positive or for one-sided limits. Just plug in the 2. So we get 2 squared minus 1, and then we get 2 times 2 minus 4. So what do we get? 3 on top and 0 on bottom. So what was our rules yesterday and the day before for if we get a limit with something over 0? What did our notes say? No solution. Not no solution. Close. D and E, right? D and E. We said D and E. Why can't we do D and E for this problem? Because it's one-sided, yeah. So we can't. So if that was just a 2, let's picture, don't do this to your notes, but let me just picture. Let's say that wasn't there. D and E, move on to the next one, okay? But there is that rule, one-sided limits will never be D and E. So what do we do? Well, this is what you're going to do. You're going to draw a picture. You're going to draw a picture, okay? So let's draw a little picture of this graph. Okay. Draw a little sketch here. Because we can't use a graphing calculator. It would be nice if we could use a graphing calculator, but we can never, limit questions never let us use graphing calculators. So we're just going to draw a little sketch. It's not going to be a whole picture. If
it was like opposite 0 over a number, would it still be the same? Like
no. Yeah, great question. So let's say it was 0 on top, 3 on bottom. Then it would just be 0.
Okay.
Yeah, great question. Okay. So where's the limiting factor again? What was, or not the limiting factor, the limiting value. What was the limiting value again to begin with? 2. It's what we plugged in, right? So that's where I'm going to focus my attention on. 1, 2. And then I'm going to go a few after and a few before. Okay. When I plugged in 2, I got 3 over 0, right? What's happening at 2? What's happening at 2?
That's the limit.
No, you're getting there. I think I know what you're saying. It's not a limit. What's happening at when x is equal 2 on the graph? What's happening? It's going to be an asymptote, right? I'm going to verify that's an asymptote. How do I know that? Because I'm going to use what I just used, what I just did, right? That's why we did vertical asymptotes before we did this, right? It's going to be an asymptote, okay? So I'm just going to draw. That's going to help me because then I know what's going on at 2. So you know what? Let me draw a different color. Use a different color. That means there's never going to be a solution at 2. Remember, solutions and limits are different. Limits are as we approach 2. Solutions are what's happening at 2. Okay? Okay. So again, we only care about one side. Which side do we care about? The left side or the right side? but because it's a negative, right? So we only care about the left side. I could care less what happens over here. I'm going to focus all my attention on this side. What happens before I get to 2? So what I'm going to do is I'm going to plug in some numbers and see what happens, okay? So let's see. I'm going to do a little t-chart. Okay. I'm going to start with -1. 0, 1. Okay. I'm going to plug it into f of x. I'm going to plug -1 into f of x and see what I get. So f of x was -1 squared minus 1, 2 times -1 minus 4. So let's see, the top is actually going to be 0. The bottom will be -6. 0 on top always means 0. So let's go make a dot. -1, 0. Okay. Now let's plug in 0. Plug in 0 to the same f of x, the same function, both top and bottom. We get 0 squared minus 1, 2 times 0 minus 4. 0 squared is 0, minus 1 is -1. The bottom I get 2 times 0, which is 0, minus 4, which is -4. And a negative times a negative makes, or negative divided by a negative makes a positive. So -1 over -4 is really positive 1 over positive 4. So I'm going to go make that dot at 0. So if that's 1, that would be like right about there. Which way does it look like it's going? As we get closer and closer to the vertical asymptote, which way does it look like it's going to go, up or down? It's either going to hug going up, or it's going to hug going down. It can only go 2 directions. Remember, it can't go through. So we can't go through the asymptote. It either has to hug and go up, or hug and go down. And we want to figure out which one. I think it's going to be going up, but let's verify. Let's plug in 1. One squared minus 1 over, is it 1 squared minus? Yeah, 1 squared minus 1 over 2 times 1 minus 4. So we get 0 over -2. That's 0. So I know it went up, but now it went down. Personally, I don't trust it anymore. I thought it was going up, but now it looks like it's going down. So this is what I would do. If you're in a position like this, do some mental math. Let's plug in another value that's close to 1.5, 1.5. And I know you can't use a calculator, but I'm going to show you a quick way of doing it. So we got 1.5 squared minus 1, 2 times 1.5 minus 4. Which y value did I leave off at? What was my last y value that I made a dot? 0. If it's positive, that means it's going back up. If it's negative, that means it's going down. So I don't necessarily care what number I get. I just want to know, is it going to be a positive number or a negative number? And that'll tell me whether it's going to go up or continue going down. Okay? So I know 1.5 squared, that's a calculator question. But if you were to square 1.5 and then minus 1, would you get a positive number or a negative number? Positive, right? Because 1.5 squared is bigger. So we get a positive on top. And then if you doubled 1.5 and then subtracted 4, would you get a positive number or a negative number?
Negative.
Barely negative, right? It would be -1, right? And what would you get if you divided a positive number divided by a negative number? Negative number. So where is that dot? Somewhere down here. Somewhere down here. I don't know where, but it's going negative. So that verifies that, hey, it's going to hug that way. And which y value is it going to approach? Never get there, but will it approach?
2.
Negative infinity. Yeah, negative infinity, right? The y value it's going to approach is negative infinity. Won't ever get there, but it will approach. So what's the answer? Negative infinity. X minus 4 equals negative infinity. So I'm going to give you a little bit of a tip here. If you're doing a one-sided limit and you initially get something over 0, that's going to tell you two things. First thing, you have an asymptote there. And second thing, your answer is either going to be negative infinity or positive infinity. Okay? So if we plug in, like we did at the beginning, and I got something over 0, it's not DNE this time because it's a one-sided limit, right? But it'll tell you two things. It's going to tell you, A, you have, at that point, X is whatever, you're going to have a vertical asymptote, and your answer is either going to be negative infinity or positive infinity. One or the other. Okay? One or the other. Okay? So let's try another one. Let's try another one. Yeah, go for it. This one should look familiar. We just did it, right? We just did it on the other side. So we actually know where the vertical asymptotes are for this guy. It's the same one we did on the other side, on the opposite side. Okay? All right. So we said for 1b, because it's the same function, we said vertical asymptote at x equals 3 and whole at x equals 1, right? Oops, not x next one. That's what we said on the front. So that means when I plug in 3, I'm going to get 0 on the bottom. When I plug in 1, I'm going to get 0 on top and 0 on bottom. That's the difference, okay? Okay, so what is the limiting value here? 3. What do we know is true at 3? Vertical asymptote. Okay, vertical asymptote. So let's draw that. Anytime we have a vertical asymptote, always draw yourself a picture. It's the easiest way to do it. So at positive 3, there's a vertical asymptote. 1, 2, 3, 4, 5. Okay. So 1. Okay. There's a hole at 1, but I'm not really concerned about 1 because that's not the limiting factor. If it said as x approaches 1, then maybe, but x approaches 3, the whole part is not really concerning me. Okay? All right. So now, what side do we care about? Do we care about the left side or the right side? The right side. So we're going to focus all of our attention on the right side. So I'm going to plug in 4, 5 to see where it's headed. Is it headed up or is it headed down? Remember, because there's a vertical asymptote here, you're either going to have positive infinity because it's going up, or negative infinity because it's going down. Only two options. Okay? So here we go. Let's plug in some values. All right, so we got 5, 4. Hopefully we don't have to plug in 3.5, but if we do, we do. Okay, so here we go. We got 1 minus 5 over x squared, so 5 squared, minus 4 times 5 plus 3. Okay. 1 minus 5 is negative 4. 5 squared is 25. Minus 4 times 5 is 20. So 25 minus 20 is 5. Plus 3 is 8. So negative 1/2. Okay, let's go make that dot. Negative 1/2. Okay. Now let's plug in 4. 1 minus 4, and then I have 4 squared minus 4 times 4 plus 3. So I get negative 3 on top. 4 squared minus 4, that's 0, because 4 squared is 16. Minus 4 times 4 is 16, so you're just 16 minus 16, and then you get 3. Negative 3 divided by 3 is negative 1. So I'm going to go make a dot at 4, negative 1. Looks like it's going down. If you want to try 3.5, you can go for it. And just to give yourself a little more confidence, right? But that's where it's headed. Okay. So the limit as x approaches 3 from the right would be negative infinity, just like the last one was. Okay. All right, so I want you to try letter C. Try letter C right now. Give letter C a shot. You already found the asymptotes for C on the front side. Okay. So, yeah, but do letter C right now on your own. See what you get. You plug in a number, and you get something over 0. That means there's a vertical asymptote at wherever that was from now on. That's true for one-sided and two-sided. The only time we care about asymptotes is for one-sided, but like if that was a two-sided, your answer would be D and E, right? Your answer would be D and E. The only reason, usually we care about vertical asymptotes only when it's a one-sided thing, because you can't use D and E. It's either going to be positive infinity or negative infinity, but yeah. Okay, so we'll only care about the left. So I'm going to plug in some numbers here. Let's see. X, f of x. So negative 3, negative 2. So if I plug in negative 3, I get 1 over negative 3 plus 1 squared. That will be 1/4. So So 1/4 is like right there. Yep. And then if I plug in 2, -2, I get 1 over -2 plus 1 squared. And that's going to be +1. This one is heading up. This one's heading up. So because of that, because there's no vertical or because there was a vertical asymptote there, you only have 2 options: positive infinity, negative infinity. And if it's heading up, that means what y value is it approaching? Positive infinity. Positive infinity. Okay. All right, we'll do D and then we'll stop from there. And then tomorrow we'll do E, and then I'll give you a few more practice problems to put in your notes. And then if we have time, we'll start the practice assignment. If not, we'll do that on Friday. Okay, so here we go, D. This one wasn't one we did in the front. We didn't do this one in the front. So I have no idea what the vertical asymptote situation is. So before you do that, plug in 2. Plug in 2. Don't worry about vertical asymptotes until we actually need them. So if we plug in 2, is there going to be a vertical asymptote at 2? No. How do I know? Because I didn't get something over 0. I actually get an answer. I get 4 over 8, which is 1/2. I don't need any pictures. I don't need any vertical asymptotes because, hey, is there a vertical asymptote? Maybe, maybe not. But at 2, there's definitely not one. I didn't need to worry about it. Okay? I don't need to worry about it. The only time I need to worry about it is when I get something over 0. Okay? Yeah.
So does that mean like for every problem we do like this, should we plug it in first?
First thing you do, plug it in. Yeah, I would. So yeah, that's a great question. First thing you do is treat them like all other limits. Plug in the limiting value. So plug in limiting value. Okay. And then that's where you got to kind of play your game, right? If you get 0 over 0, that means we do what we did for practice 2. Keep going. If you get 0 on top, nothing on something else on bottom, your answer is just 0. If you get 0 on bottom with something else, now if it's a one-sided limit, D and E. If it's a two-sided limit, that means you got a vertical asymptote there. Okay? And then from there you go. From here, draw a picture. And then if you get this guy, draw a picture like we did before. So every time you do a problem, you hope, plug it in and I'm done, like we did on this one. Whether it's a one-sided limit or whether it's a two-sided limit, plug it in and hope we get something. If we don't, then we can deal with it. 0 over 0, use the rules you did for practice 2. 0 on top, something on bottom, answer is 0, move on. If we get something like this, that means it's a vertical asymptote there. Okay? Hopefully that makes sense. So it gives you kind of a bounds or, you know, how do I start? That's the hardest part, always. How do I start? Plug it in and go from there. Okay? Because the first thing, if you're asking me a question, the first thing I'm going to say is, did you plug it in? And if you said, yeah, then I'm going to be like, okay, which one did you get? And then we'll go from there. Okay? We'll go from there. All right, so we'll finish the last one. I'll give you a few more practice problems tomorrow, and then if we have time, I'll give you the practice. If not, we'll push the practice to Friday, just depending on how we're feeling. Okay? Any questions? Was there any questions on practice 2 that you saw that you want me to talk about? Any questions on practice 2? It's not due till tomorrow, but if you have any questions,